is the function g continuous at x equals 5? Why or why not? So what I did was I graphed this piecewise function using Desmos graphing calculator and saw that this graph, well, from the left and from the right, they meet at 513. It's continuous at x equals 5, yes. But how do we write that down using the definition of continuity? So graphically, I want you to check it, okay? Our conclusion will be yes, g is continuous at x equals 5 because we see it, okay? They meet at 513. But here's what you're going to have to do using the definition, okay? So number 1, part 1. Show that, well, I'll ask the question, is g defined at x equals 5? That's the first question we have to answer. And if it is defined, what is g of 5? Okay, so let's define it. Let's find it. When x is equal to 5, we have to use this bottom quadratic, right? Because it says x is greater than or equal to 5. The equal to bar underneath it. This part right here tells us that we need to use x squared minus 2x minus 2 when x is equal to 5. So plug in 5 into the bottom piece, okay? So I'm going to write that down over here. So we have 5 squared minus 2 times 5 minus 2. And that's 25 minus 10. I'm going to write this down. 25 minus 10 minus 2. That's 15 minus 2, which is 13. So yes, a g of 5 is defined, and it is 13. And I'm going to write this down, and I'll even box it on the side over here because that's what we're going to have to use to make our conclusion, okay? The first thing you're going to have to do is find what the function value is at that given point. So g is defined at x equals 5 and the function value is 13. And that matches our graph right here, right? But on your test, I'm not going to give you the graph. I'm just going to give you the function and ask you to do that. Now, number 2. What's the second question that we have to answer when we are doing continuity? Does limit as x approaches 5 of g of x exist? In order for you to see if the limit exists, you will have to find the left-hand limit and the right-hand limit and compare them. So in other words, like from the left side, what is this function value approaching? From the left side, this function was going up to 13. From the right side, this function was going down to 13. So left-hand limit, right-hand limit, by just the look of this graph, they both are approaching 13. But show that algebraically, okay? So what you will do is, for the left-hand limit, you're going to use this top piece, okay? Because when it says x is less than 5, numbers that are smaller than 5 are to the left side of it, right? So take a look. I'm going to write this down with limit notation, okay? The left-hand limit. Limit as x approaches 5 from the left of g of x is equal to the answer that we will get if we plug in 5 into this red circled rational expression. I'll set it up, but I'm going to open up a graphing calculator, scientific calculator to evaluate it, okay? So what's that going to be? I will have to plug in 5 into this. 2 times 5 squared minus 7 times 5 minus 15 over 5 minus 5. Uh-oh! I can't do it this way, right? I can't use direct substitution because here I will get 5 minus 5 to be 0. So this will be that indeterminate form. So what I will have to do is factor and simplify, okay? So let me write down more work, and I'm going to add a page because this will be a little more work than just this. So what are we doing here? Let me copy this. I'll copy this down so that I don't have to write this, again. Copy. I'll paste it down here. All right. And I'm going to need a piece of paper to do this work. I'll add a page. All right. So let's factor 2x squared minus 7x minus 15. Okay? I'm erasing this page number. Limit as x approaches 5 from the left of. Now you have to factor this trinomial. I'm going to factor this over here using AC method, okay? So I'll slide this 2 to 15 and get x squared minus 7x minus 30 by doing 2 times 15. And I'll factor this. 10 times 3 is equal to 30. And if I make the 10 a negative and 3 a positive, I can add them to get negative 7. But don't forget, I have to now divide both of these numbers by 2. So, if I simplify this, I will get x minus 5 because 10 divided by 2 is 5. But over here, 3 cannot be divided by 2. So in that case, what I'm going to have to do is I'm going to have to bring this bottom up in front of the x. Well, that's one way of factoring a trinomial, but you use the method that you learned, okay? You use the method that you're comfortable with. But that's how I will factor this trinomial, and that's the numerator. So let me put that over here. X minus 5, 2x plus 3. And the denominator is still x minus 5. But what will happen now is, never mind, I'll just write it. X minus 5 will cancel out. Look, cancel, cancel. So now, when we try to evaluate this limit, we will have limit as x approaches 5 from the left of 2x plus 3. All I need to do is plug in this 5 in here. 2 times 5 plus 3. And that's equal to 13. Wow. So in order for me to evaluate this left-hand limit, I had to use factor and simplify method. But I see algebraically that this is going to be approaching 13. Now let's do the right-hand limit. Limit as x approaches 5 from the right of g of x. That's going to be limit as x approaches 5 from the right of the bottom piece of this piecewise function, which is this. Oh, thank goodness, it's just a quadratic. We are not going to have to factor and simplify this one. So I'll copy this and I'll put this down here, okay? So let's evaluate this by just direct substitution. So that will be 5 squared minus 2 times 5 minus 2. And I remember doing this. This was 25 minus 10 minus 2, right? 15 minus 2. That got us 13 earlier when we evaluated the function value. So look, notice that the left-hand limit came out to be 13. The right-hand limit came out to be 13. They are the same. So what we can say is, yes, the general limit, well, I'm not going to say yes here. I'll just say limit as x approaches 5 in general of g of x is equal to 13 because the left-hand limit and the right-hand limit are the same. Okay, so I'll circle this. Hold on. I'll box this actually. Now I want you to look at the two gray boxed expression here. Number 1, we show that the function value at 5 is equal to 13. Number 2, we show that the limit of g of x as x approaches 5 is equal to 13. Not 3, I mean 13 right there. Okay? they are the same, right? Because they are the same, now we get to make a conclusion, okay? So make a conclusion now. We're going to say that g is continuous at x equals 5 because g of 5 is exactly the same as the limit this g of x is trying to approach as x is approaching 5. Okay? And that's how you can show by, algebraic work, a limit work, that a function is continuous at a given point.